Welcome back to Mechanical Engineering Design. In this episode we are going to design a hopper. So this hopper has a rectangular top and then circular bottom. Let's proceed to design. So go to File, New, Part. Okay. Click on Top View, Sketch. Now pick on Center Rectangle. Click Center, drag. Now right click, Sketch. We are going to give a length of 500. Enter. And then a width of 300. Enter. So for us to obtain a sheet metal, we have to break. So pick line, locate the center here, drag it to any height, right click, construction geometry. So go to offset. We give a small offset distance of 0.5 mm. Then select this line and ensure it is bi-directional. Tick bi-directional like this. Okay. Now select the two lines and convert to construction geometry like this. Now go to trim. We are going to trim these lines like this. We give it a break here and then okay. You can exit sketch. So in isometric view, we are going to go to features, then select reference geometry, plane. So our plane, our first geometry will be top plane at a height of 250, but we'll flip downwards like this. Okay. Now click on this plane, sketch. Pick on circle, click center, drag. Go to smart dimension. Give a diameter of 200. Now pick line, click quadrant here and drag it upward any height. Click and then right click, construction geometry. Now go to offset again, 0.5 mm. Click this line, ensure bidirectional is on. It's ticked like this. Okay. Now select the two lines, click Control and hold, and then select the second line, construction geometry like this. Now go to trim. We are going to trim the two lines, this one and this one. You see? Then okay. Now exit sketch. Isometric view. Now we are going to hide this plane. So go to plane, then hide this way. Now we are going to sheet metal, select lofted bend. Here we have to select profiles. First profile as this rectangle, then second profile, this one. See the preview. Now here, our first option is code tolerance. So you can give a face value of 0.5. Then sheet parameters is 1 mm. And here you can reverse direction. You see, reverse. It will go inside. See, this is outside, reverse, goes inside. So you leave it inside. Now, our second option is number of bends here. So here, depending on the number of bends you want to apply or accuracy that you need, for example, when you apply like 2 bends, see what happens. So from this corner, only 2 bends are applied, but at the bottom you obtain a square cross section. Does not follow a circular profile. Now when we increase the number of bends to, let's say, 4, you see what happens. These are 1, 2, 3, 4 bends on each corner. 4 bends. When you increase to 6, see what happens. So 6 bends per corner. So depending on the level of accuracy that you want, then you can select, you can enter the number of bends. Our next option is segment length. Now what this one means is along this circle, there is a distance between the bends or segments. So for example, this is 50 mm will give 1, 2, 3, 4, 5 bends. And as you reduce, let's say to 30, the number of bends increases to 1, 2, 3, 4, 5, 6, 7. 7 bends. If you give 10, so the bends become too many. So for now we leave at 50. Next option is segment angle. What this one means is angle of reduction. Like for example, from this face, the first bend will be 10 degrees. As you go 10, 10, that order. So if we increase to 30, you see, so we leave it at number of bends, and we give it 6 bend max. Now, one important thing is how this corner is made. There is this option, you can refer to endpoint. Click here and you see what it does. It will be referring these bends to this point, but there will be distortions, as you can see. So I don't think this option will apply. So we leave it at unticked. Now another option, we can use gauge table, sheet metal gauges. The system will use the parameters that have been saved to apply the bends. So if you tick use gauge table, you have to select the table that you want. So you can use sample table, still English. See? Now, after selecting this table, we have to select sheet metal parameters, which is the sheet metal gauge. So gauge ranges from gauge 3 to gauge 18. So gauge 3 is a thick sheet, but as you go up to sheet 18, it's thin. So you can see this is gauge 18, that's gauge 10, you see thickness increases, that's gauge 3. See? So but we'll not use gauge table for now. We leave it on number of bends, 6 bends. Bend allowance, we leave the default 0.5. Then you can select use relief ratio. Don't forget sheet metal parameters. We'll give a thickness of 1 mm. Now click OK. You see what we got. So the next thing, we are going to obtain flat pattern. So we are still on sheet metal. Go to flat pattern. This is what we get. Go to front view. This is the profile. Now to see the bends, we have to go to view here, then hide stroke show, and go down to bend lines. Just click. You see what we get. So this is the length, the width is here, this is another width, and this end point will be joined with this one. So you can untick. You see? So if you want to manufacture, just go to save as. Then on file type, click on DXF or DWG, give a name, Lofted bend, then save. So it will ask you to export a sheet metal. You can export geometry the way it is. Tick on bent lines, very important. Click OK. This is the preview, so click on save. So this is what I had for today. See you in the next video. Thank you for watching. Don't forget to subscribe and turn on notification so that you will not miss my next upload. Thank you.